Hello and welcome to today's lesson on domain and range. We're going to be looking at topics covered under the standard 2.1D in Algebra 2, and then also the topics that are covered in the lesson on Study Island called domain and range. So if you have any questions on those, this is the place that you want to be today. And we are going to be looking at domain and range. So remember, domain is the set of all x values and range is the set of all y values. And you're also going to want to make sure that you're taking your notes as we go through this video, and that way you have them to refer back to and to study afterwards. And then you also remember, if I go too fast, you can pause or rewind so you can get caught back up, and you can even pause at the beginning of a question, work the problem out yourself, and then use the video to check yourself, and that way you can get a good gauge of how well you're learning about domain and range. So I'm so glad that you're here, and let's go ahead and take some notes. So we're looking at domain and range, so we want to talk about those definitions first. We have this acronym DIX to remind us what the definition of domain is. So domain is all of the inputs or x coordinates. And then range, we have the acronym ROY. And range is a relation, is the set of all outputs or y coordinates. And so basically you're listing or talking about what is all the x values you're allowed to have for that relation and what is all the y values you're allowed to have for that relation. And there's a couple of ways that you could see the domain written. Sometimes they use set notation, which is the curly Q parentheses. Sometimes they use algebraic notation, which is with less thans, greater thans, equal tos, not equal tos. And sometimes they use interval notation, which is a hard parenthesis and or a curved parenthesis. So you usually use set notation when the graph is discrete. So that means that the graph is a bunch of points. It's not a line. And so that way you can just list all of the x coordinates in the range. And sometimes you'll see it like this, and other times you'll see it, well, with an x, then a colon, and then the x values that exist. And sometimes instead of the colon, you have a straight line. So these are just all different ways you could see it listed using set notation. Algebraic notation is it's without any parentheses, and you're just saying y is always greater than 5. Or x is between -2 and infinity. And so there are some examples there. Interval notation, it's important that you know that the parentheses are points not contained in the domain and range. So that means it would, here it's a parenthesis. That means it would be, you could have 73.999, but you could not have 74. You would have everything from 5 up to 74, but not including 74. Whereas when you have a bracket, that does include that number. So here you could have 5, you could have 2, you could have 4, you could have 3. And if you are using infinity or negative infinity, it goes forever in one direction or both directions, then that always has a curved parenthesis. So this question here asks us to find the domain of the square root of x, and it's nice enough to go ahead and give us the graph. So when we're looking at domain, we're looking at x, and x runs right to left. So we're basically looking at where does the graph begin and end, right to left. So you can take two pieces of paper, and I'm using my blue squares here as paper, or rectangles, and put them at the beginning and end on the left to right. So my graph begins here on the left. However, there's an arrow here, so that means the graph goes on forever and ever into the right direction. So I'm not going to have an ending on my right. It's going to go forever into infinity. So here, I'm going to look at my x value for where it begins here on the left, and then my x value there is 0, and my graph exists at 0, so I'm going to have a hard bracket, and then it goes on forever into infinity, and I always used a parenthesis with infinity, so that's going to be my domain, which is choice A. So this graph here, they're asking us to find the domain again. But this time, this graph on the left side, it's going to forever keep going left. Very, very slowly, but it doesn't ever stop going left. So it's going to go forever into negative infinity. And then it does the same thing on the right. It keeps going right, ever so slowly, but it never stops going right. So it's going to go forever into positive infinity. So that means that my domain is from negative infinity to positive infinity, and I use parentheses for either infinity. And so that makes my answer here C. Right, here is asking us to find the domain of the same equation that we had in question 1, only this time they don't give us the graph. So the way I would do this is I would use my personal graphing calculator or the one provided on the EOI to go ahead and graph it, because I find that's the easiest way to find the domain is by looking at the graph. If you don't want to do it that way, then you have to think about, okay, what values of x am I allowed to have here? What kind of numbers am I allowed to have underneath the square root? Well, I can never have a negative number, I can have 0, and I can have positive numbers. So that means that my domain is going to start at 0 and go up forever. So the way that I would represent that is x is always going to be greater than or equal to 0. And that's what letter D is telling us using set notation. Okay, number 5. It's the same thing. They're asking us to find the domain, and once again, they don't show us the graph. So that means we're going to have to think about what values I can have for x. Well, I have a square root, and I can never have a negative number under the square root. So that means that x minus 7 is always going to have to be greater than or equal to 0. Because it can never be negative. So then I'm going to solve that for x by adding 7 to both sides. X is greater than or equal to 7. And that's going to be my domain, which is letter D. Alright, so once again, they don't give us the graph, so you have the option of just putting this into your graphing calculator and graphing it and looking at the graph there and using your pieces of paper, which I think is the easiest way. But if not, then you just need to know that when we're dealing with a quadratic, and a quadratic means that the highest power on the variable is the squared, is that a quadratic graph is always a U shape. And it's either a smile or a frown. And I actually know this one's going to be a frown because the x squared is negative. So I'm going to think about this graph. It's forever going to be going into the negative direction ever so slowly, and forever into the positive direction ever so slowly, no matter where that U is on the x and y axis. So I know that it's going forever into negative infinity and positive infinity. So that means it can be any number in the world. So that means my answer choice here is going to be B, because this fancy R here represents all real numbers. So that's saying every number can be x. This question asks, what's the domain of the function below? Once again, you could go ahead and graph that and then look at the graph. However, if you don't want to do it that way, then you need to think about, okay, what am I not allowed to have in this equation? Well, I'm not allowed to have a 0 in the denominator. So what value of x will make that denominator 0? So I can set the denominator equal to 0 and then solve for x. So here, the value that will make the denominator 0 is when x equals 5. 5 minus 5 is 0. That makes sense. So that means x cannot equal 5. So I'm going to go over here and look at my answer choices and see which one of those says x cannot equal 5. Well, A, it says it can be 5 and lower, or it can be 5 and bigger. It has this equal to part, so it says it can equal 5, so it's not going to be A. B is saying it can be every number from negative infinity to positive infinity. So it's not going to be B. C is saying it can be x is greater than 5. Well, what about numbers like 4? It could be 4. So it's not going to be C. And then D is saying it can be all numbers less than 5 or all numbers greater than 5. But it does not have the equal to part. So it can't be 5. That's the one I'm looking for. That's the one that accurately describes the domain I found. So it's going to be D. Now this graph here asks us to find the range of this function. And so I'm looking at, okay, where does this graph start and stop going up and down because it's range? Well, this graph here, it's going to go forever down. So it's going to go forever into negative infinity. And then it's going to go forever up into positive infinity. So it goes from negative infinity to positive infinity, and the answer that gives me that as a domain or as a range is letter D. So this question here is asking us to find the range of this graph. And so I'm looking at where does this one start and stop going up and down, because we're looking at range, which is y. So this graph here, at the top, this is where it begins. But at the bottom, it keeps going forever and ever down. So it's going to go forever and ever into negative infinity. So I'm going to look at y, where I laid my piece of paper on the y-axis at the top here. And my y value there is 5. So that means my range is going to go from negative infinity through 5. And it can be 5, so I'm going to use a bracket. And that is what letter B says. Here it gives me an exponential function in its graph and asks us what the range is. Well, here the range is going to go ever so closely to this y value, but it actually never touches it. And then it keeps on going up forever. So it doesn't have a starting or stopping point going up. So it goes forever into positive infinity. My y value here is -2. And it's an exponential function, so I know that it has a horizontal asymptote at the bottom, which means that or asymptote is a line that a graph gets closer and closer to, but never actually touches. So that means it never actually touches -2, so it just gets super close to it, so it can't be -2, so I'm going to use a parenthesis this time. And then I'm going to go forever up into positive infinity, and I always use a parenthesis for that too. And so that is going to make my answer letter C. The easiest way to do this problem, and when you don't have a graph, is to go ahead and graph it. But if you don't want to do it that way, I can show you how you can do it. One way is to know, you have to know what the parent function 1 over x looks like. And that looks like this. It gets really close to both axes in the first quadrant, but never actually touches it. And then it does the same thing in the third quadrant. It gets closer and closer. So that's a rough sketch. And so I know that when I add positive 11 to the x part, that's going to shift it to the left 11 units. It's going to shift my parent graph to the left 11 units. So as I think about that, and I'm looking at it up and down, I realize that this part, it's going to go forever up into positive infinity. And it's going to go forever down into negative infinity, but it's never going to actually touch the x-axis. So that means there's never going to be a part of the graph where y equals 0. So you're going to have it forever down from y equals 0 and forever up, but it's never actually going to be at y equals 0. So that means my range is going to be letter D. Once again, if you're trying to find the range and it doesn't give you the graph, go ahead and try graphing that on a graphing calculator. Or you can think about, what does this parent graph look like? Well, the parent graph of an x cubed is a snake. It looks something like this. It goes forever into positive infinity up and forever down into negative infinity. So that means that any x cubed graph is going to have a range from negative infinity to positive infinity, and the answer that gives me that is letter D. Now I'm looking at the range of this function, And once again, I would graph that on a graphing calculator, but if you don't want to do that, then you have to think about what is the parent graph look like of a square root. Well, the parent graph of a square root looks something like this in the red. And so I know that just because I added 20 in the parentheses with this x, that's going to shift it to the left 20 units. It doesn't shift it up or down, so my range isn't affected. So here, it's just shifted over 20 units. So something like that. And so it starts, it has a starting point here on the bottom, but it keeps going forever up, ever so slowly, into positive infinity. So my y value at where it starts is 0. So that means it's going to start at 0, and I can have 0, and it goes forever into infinity. So the answer here that shows me that I can have 0 and up is D, where it says greater than and equal to 0. Thank you for joining us today, and I hope you learned something new.